Hello and welcome back. Today we will be discussing time plots. All right, so what is a time plot? Let's take a look. Say you recorded the outside temperature every day for a week. How would you display the data to show how it changed over time? Use a time plot whenever observations are collected over time, such as daily temperatures, monthly sales, yearly population, stock prices, or heart rate during exercises. This is going to look like a line graph, but we could also call it a time plot because it's over time. All right. Some vocabulary words to go over. Time plot, also known as time series graph. A graph showing data in chronological order. Trend, this is a key word here. Overall direction of the data. Seasonal pattern, a pattern that repeats at regular time intervals. Cycle, long-term rises and falls that do not occur at fixed intervals. And an outlier, which I've discussed in a previous video, a point that is universal or unusually high or low. Okay. How to construct a time plot. Step one, label the horizontal axis with time. Whenever we're graphing anything, the horizontal axis, or let's make a note of it here, the x-axis. X-axis is always time. Always, 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 100% of the time. You should never have time in the y-axis. Step two, label the vertical axis with the measured variable. Whatever we are measuring gets the vertical axis or the y-axis. I'll keep these there. Step three, plot each observation in chronological order. Step four, connect constructive points with line segments. And lastly, step five, give our thing a title. Okay, let's take a look at an example. So I had to zoom out so we can make sure we fit everything. Our example here is daily high temperatures in degrees Fahrenheit. And here we have the days of the week, Monday through Sunday, with the high recorded temperature of each day. All right, so step one, we construct our horizontal axis or x-axis. I said time before, days is a unit of time. So our x-axis is the days of the week. We start at Monday at through Sunday and then Sunday. Step two, the vertical axis is the temperature. Now, there we go. Let's see if we can get it all in there. So now first, I include a little break here because we skip 0 through 71. And then if we look, whenever we construct a graph like this, you want to be mindful of the given data. So just looking at this thing really quickly, we see the lowest recorded temperature is 72 and the highest recorded temperature is 84. So that's the range I'm working with. So I don't need more or less points than that. I want to keep everything within those points. So you can see here, I make my top point 84 and I made the lowest one 71 really just to make it nice. But here's our 72. And also we could see these each 71, 2, 73, 74, they all go up by 1. I skip labeling every other one. You're allowed to do that. It just makes it a little bit easier to construct and to look at. We can figure out that this line here is 81 if 82 and 84 are outside of it. Okay. So anyway, this is what our vertical axis should look like. We label it, it's temperature, degrees Fahrenheit. So important that we always label our axes. It's a huge mistake I see all the time. Whenever somebody's reading these things, they need to know what we are talking about. So you must have these labeled. Sometimes it's obvious, sometimes it's not. Doesn't matter. Assume everybody's an idiot. Label the axes. All right. Step three, we plot each temperature. Monday was 72. Tuesday was 75. Wednesday, 78. Thursday, 77, Friday 81, Saturday 84, and Sunday is 82. Okay, so each dot coordinates to the day of the week and its recorded temperature. Step four, draw a connecting line to each point. Plain and simple, just connect the dots. And our last step, step five, give our thing a descriptive title. I decided to call ours daily temperature because that's what we're recording. Okay. And that's all there is to it. I made a little note here. What's the trend of this thing? So the trend, you could pretty much just look at the start and end points. Starts here, ends there. That's an upward trend right there. Okay. Overall, the weather has increased over the course of 7 days. Upward trend. Cool. Interpreting the data, here we have some questions here. Is this an increasing or decreasing trend? Well, we just discussed it increases. Are there any sudden jumps or drops? You could say here, this we can call any increasing interval a jump and any decreasing interval a drop. So we could say here, let's do a different color. Let's do green. We have jump and jump. And then here we have drop, drop. Okay. So two intervals have, oops, highlighter. Two intervals, Monday through Wednesday, the weather jumps, and then Thursday through Saturday, the weather jumps, and then Wednesday to Thursday, it drops. Saturday to Sunday, it drops. Is there a repeating seasonal pattern? So here you could see we don't have enough data to really answer that. We would need probably a year's worth of recorded temperature, or maybe at least a couple of months. This is only given 1 week. We don't have enough data to answer that one. Any outliers? So in a previous video, I discussed how we can calculate our outliers using the 1.5 times IQR rule. We can use these data points to calculate that. Just looking at this, it's safe to say there is no outlier. Our high is 84, our low is 72. That's a range of what, 12 over the course of 7 days. If there's no big enough jump or drop to call any of these points an outlier. If we had, say, Thursday, say our temperature was 30 degrees, that's crazy outside of our range here. That would be an outlier. Or if Saturday, instead of 84, maybe it was 104. That's crazy outside of our range here. Those would be examples of outliers. Again, we can calculate it, but we could just look and see this is a close enough range. There's nothing really here that's manipulating or skewing our data. So no outliers. No. What might happen if the trend continues? So just based on the trend, again, we established overall it's increasing. If we just look at this, we could say that, oh, well, because it's increasing, if the trend continues, it's going to continue to increase. That's something we would observe just from looking at our graph. However, we do know weather is cyclical. We do know it gets hot, then it gets cold, then it gets hot, then it gets cold. Looking at global climate change patterns, the trend is everything's increasing. But over the course of a year, while there might be minor increase, it stays typically within the same range. So again, just to bring the point home, looking at this, if we only knew this, it would be safe to say the trend is increasing and that if the trending continues, it will get hotter. But we know that's not quite how temperature works. But for something like stock prices, you might be able to safely make that assumption. Okay. Cool. So here we have some real world applications. Weather data, like I mentioned before, stock prices, population growth, sports statistics, website traffic, and disease tracking. And common mistakes we see, plotting data out of chronological order. So we started on Monday instead of Sunday, but you can't go Monday, Wednesday, Sunday, Tuesday, Thursday. No, it has to be in order of whatever you're looking at. Time, well, which is always forward. Forgetting to label the axes. Must label the axes. Again, assume whoever is reading this is an idiot and has no idea what you're talking about. All the information must be in front of you. Using uneven time intervals. Monday, Tuesday, Wednesday, Thursday, Friday, they're all the next day. You could do the next 2 days, but you must be consistent with the next 2 days. And likewise, you could see my y-axis for temperature. It increases by 1, but it's labeled by 2s, both consistent. We can't just jump around. And if you skip a bunch of values, you include a little break right here. Using a time plot for categorical data, we would use a bar graph for that. And assuming trends always continue, huge mistake. And like you see that mistake made with like stock market's a good example. Sometimes it's safe to assume a trend will continue if businesses continue certain practices, but there's always certain variables that you cannot always account for. And you have to make educated assumptions when looking at trends and how they continue. And like I said, with the weather, You know, you might want to assume like, oh, it's got overall it got warmer throughout the week. It's going to continue to get warmer, but we do know seasons change and it gets colder again. So you can't just assume a trend will continue forever. Okay. All right. Cool. And now we have a practice problem here. Create a time plot using monthly rainfall for our months January through June. Describe the overall trend. And would a time plot or bar graph be better for your favorite pizza topping? Explain. All right, I'll give you a minute to pause the video here and take a stab at this. All right, hopefully you worked on this. Let's take a look. So if you made a time graph that looks something like this, you would be correct. In the x-axis, we have January, February, March, April, May, June with our axis labeled. And in the y-axis, rain, we're going to assume it's in inches. It didn't really tell us, but we want to label whatever unit it's in. So rain in inches. I put a little break here because we skip 0 through 1.6. And you can see here, I go up by 4s. It's consistent with how I increase 4, 4, 4, 4, 4. And I also skip a line, so you can put 2 there. And then if we have to work in between points, we're allowed to do that. So January, see, I worked in between a point right here. January was what? 2.1, and it's in between 2.0 and 2.2. February is 1.8. Oops, there we go. March is, this should be 2.7, 2.8, 2. Yep, this is 2.7 here. April is 3.0, May 3.6, and then June is at our height, our max at 4.2. It's 1 dot above 4.0, and going up 1 dot is going up 2. Something else you could do, and I would recommend doing, like, I have this tool here to make it nice and easy so that everything's perfectly, you know, symmetric and perfectly spread out. If you're just working with regular paper and you can't make it as neat as this, you're allowed to just label the top of the points. I do this in my bar graphs and histograms, so we can put here, okay, this is 2.1. We could put here, this is 1.8. We could put here, this is 2.7. We could put here, this is 3.0. 3.6 and 4.2. Just so you see here, this line goes out to there, which is above the 4.0. Okay. So again, you're allowed to do that. Your teacher would probably appreciate it because, again, if you're not as to scale as I am with the grids helping me out, your teacher can clearly see like what point you're trying to get across. Okay. The overall trend is upward. Sure, we have a little dip here, but then it goes up. From where we start to where we end, we increase by what, 1.9 units, 1.9 inches. So, and then you could see with the highlighter, that's our overall trend. Okay. So overall trend upward. And then our last question of, would a time plot or bar graph be better for favorite pizza topping? A bar graph would be better. And it's because favorite pizza toppings is categorical. Okay. It's not a measurement of time. It's a topic. So we wouldn't use our time plot. We'd use a bar graph. Cool. And that's everything I have for you today. Thank you for tuning in. As always, a link to the notes will be in the video description, and I will see you next time. Take care.